Yo, what's up my fellow atoms? My name is Nathan Baker and I'm joined with Gia, and today we are going to be doing a chemistry question of the week. Yeah. Okay, so today's question, we're going to be looking at an unknown compound A and trying to figure out what compound A is. We're given the elemental composition, the mass spectrum, and the IR spectrum. And there's a very specific order to work out these kinds of questions, and it's very formulaic. And I believe you'll be able to get 9 out of 9 on your A-level exam. So I've drawn our table, getting ready to work out the composition to find out the empirical formula. We're going to be using percentage mass. I'm just assuming it's all 100 grams. So that means that the remaining hydrogen is 100 minus 69.7 minus 18.6. And that gives us an answer of 11.7. So hydrogen will have 11.7, oxygen 18.6, and carbon 69.7. Now the relative atomic mass for these elements, as I'm sure you know, is 12 for carbon, 16 for oxygen, and 1 for hydrogen. So to calculate the moles, we are just going to be doing mass over the relative atomic mass to get the moles. So 69.7 over 12 gives us 5.81 moles. 18.6 over 16 gives us 1.1 or 1.2 or 1.16 moles. And obviously hydrogen would just be 11.7. So that ratio, now we want to figure out the ratio to find out the empirical formula, which is literally just the ratio of atoms. So 1.16 will be 1, hopefully. Now we're going to do 5.81 divided by 1.16, which gives us 5.0. And 11.7 divided by 1.16 gives us 10.0, or 10.1. So now that we have the ratio of elements, we will be able to tell the empirical formula. Which will be 5 carbons, 1 oxygen, and 10 hydrogens. And the relative formulaic mass of this will be 5 times 12 plus 16 plus 10, which is 86.
Cool, right, so carrying on from what Nathan said, we've got the empirical formula, which has the MR of 86. Now we also have this M plus 1 peak, and that has the MZ value of 87. However, we need to consider that this M plus 1 peak is actually an isotope of hydrogen, giving it extra mass. Therefore, we can take off 1 to get our actual M plus peak, which is 86 as the mass to charge ratio. Since the M plus peak is the same as the MR for the empirical formula, we can deduce that this is actually the MR of the actual thing, and therefore the formula is the molecular formula of the structure. Now let's move on to our IR spectrum. We have a deep peak at 1720, but nothing for alcohols here, which is so no broad peak for an alcohol or carboxylic acid. This 1720 corresponds to a C double bond O as the pendulum falls off. So we know that it needs to be a ketone or an aldehyde. With 5 carbons, you can have 3 structures of this. You can have pentanal, pentan 2O, or pentan 3O. So to consider which one of these it actually could be, we need to go back to our mass spectrum. We see that there's a MZ value, a peak at 27. Now, this peak can only be formed by that C double bond O, because it's 12 plus 16. Sorry, I meant 28. Therefore, we're going to have to look for a compound which cannot actually form that peak. And we get that pentanal can't form it, because if you take the structure for the pentanal, you'll see that this C double bond O has a hydrogen attached to it. I've not shown all of the hydrogen in skeletal, but actually it does. And therefore, it will always form a 29, but never a 28 peak. So, the only structures that we can form from this information at the moment is pentan 2O and pentan 3O.
Yo, I'm back. So the question, looking back, was to determine the molecular and structural formula of A. We have the molecular formula, and we have two possible structural formulas. But I've never seen a question like this, but it's a tricky one. How can we tell these two apart? Well, what they wanted us to do, and I'm not entirely sure the likelihood of this coming up in an exam, but it could, right? It could come up, as far as we know. So look at this. We know that there was this carbon and oxygen fragment here that was 28, and you know there was the carbon and oxygen fragment here, which is 28. And here is that peak. If you look at it, it's roughly half of this peak. So the abundance, this peak here, the carbon and oxygen fragment, is only forming, let's say, 1 relative time. But this peak here is double that. So that means that this peak should be being formed in 2 alternative ways, 2 directions to form it because it's more abundant. So looking at these 2 structures, you can see that this structure here can only form the peak at molecular ion peak at 29 once, but this structure here can form it twice. Therefore, this is the structure of compound A.